by using the tools you have used in the course of differentiation. And let's look at the current picture. The fact is that you see, it would be very helpful if you understand the local maximum point and local minimum point for the function f, and also where is f going up, where is f going down, and these are based on the use of the f prime, which is the sign table of f prime basically. And moreover, we can look at the point of inflections. It would be very helpful if you find all of these. And if you fully understand the shape of the f, where is f concave up, where is f concave down, it would also be helpful. And the fact is that, mathematically speaking, this part is related to the use of the f double prime, which is the second derivative, and is sign table. So if you get all this information, it would be very helpful for you to find the shape of the graph of f of x. And sometimes you may need more information. For example, if you can find y-intercepts, or sometimes even more, if you can find the horizontal or vertical asymptotes, it would also be helpful. And anyway, basically, these are the information you need to sketch the graph of y equals f of x. And we'll look at the concrete picture. So please look at the current problem. I'm giving you the graph of y equals f of x now. So can you tell me some information like, can you find some local maximum, local minimum? For the whole curve, I think the only local maximum occurs here. That's the only point where you are turning your direction of traveling from going upward to downward, right? So the local maximum actually occur at x equals 5. This, this point is clear. We don't have any local minimum because you're not going to go down and then go up for the whole graph described here. And I think from there you can also tell me where is f increasing or decreasing. F is actually increasing for all the points before 5. It's like minus infinity up to 5. And moreover, f is decreasing all the points after 5 because you keep going down after 5, right? So is 5 to infinity for f to be decreasing. And that's the first bit of information. And then, can you tell me some points of inflections on the graph? Just to remind yourself, points of inflections are the points where the concavity change. For example, let's look at this point. When x is 1, you see, before 1, the shape of the graph is concave down. It's like concave down, concave down. And after 1, it is concave up. It is up, concave up. So it means point. We get the first point of inflection, and moreover, at the point x equals 2, you see what happens? It's concave up and then concave down, right? So x equals 2 also the second point of inflection. How about x equals 3? You see, it's concave down first and then concave up. So it's once again a point of inflection, and moreover, for the point x equals 4, it's concave up first and concave down. So x equals 4 also. So basically, you have 4 points of inflections. And can you tell me where is the graph concave up? Concave up occurs between 1 and 2. You see this between 1 and 2. And then concave up occurs again between 3 and 4. And for concave down, all the points on the left interval, which is from minus infinity up to 1, is concave down. And moreover, from 2 to 3, it is concave down. And one more, for all the points after 4, it is just concave down all the time. So these are basically the answer to this problem. And next one, we'll do an exercise. So in this exercise, you're given a function f, and you have to try to sketch the graph by first finding all these local maximum, minimum, and point of inflections, and where is f increasing, where is f decreasing, and you have to also find where is f concave up and concave down. So let's do this exercise together. Mathematically, you need the f prime and f double prime, and their sign table. For f prime is going to be 6x squared minus 30x plus 36. So to find the critical number, you can set it 0, and you can solve it yourself. Actually, there are two critical number, 2 and 3. So we can actually look at the sign table for f prime. And please do the evaluation yourself. What you need to choose is you have to choose randomly 1 point for each interval. For example, for the first interval, I can actually choose 0 and evaluate f prime at that. For the middle interval, I can choose f prime of 2, 5. For the last interval, I can choose f prime of 4. And the evaluation is as follows. Please look at this picture. I can just put the sign in. It's gonna be positive, negative, positive. And once again, it's a good habit to draw the tangent direction for each direction based on the sign of f prime. So positive means going up, negative means going down, and positive again means going up again. So let's write the answer down for the local maximum, local minimum, and the increasing and decreasing function f. So you see for the point x equals 2, the tangent direction is going up first and then going down. So it means that at the x equals 2, we actually have the local maximum. And similarly, let's look at the second point, x equals 3. What you have is going down first and then going up for the tangent directions. So in that case, it means it is a local minimum 3, comma f of 3. And you can do this calculation based on the function f. So the first point is going to be 2, comma 33. And the second point is going to be 3, comma 32. And these are the 2 points that are quite important when you try to sketch the graph. And anyway, f is increasing for the left interval, minus infinity to 2, and for 3 up to infinity. And f is decreasing for the middle interval, which is 2 to 3. And it is the answer, at least, we can get by the use of the sign table of f prime. And we also need the f double prime next. So for the f double prime, it's going to be 12x minus 30. We can make it 0 and solve this. We get that x is 2.5. So it means that on the sign table of the f double prime, we only care about one marking on the x-axis, and there are actually two intervals. So please feel free to choose some points. 1 point for less than 2.5. Let's say you can choose 0. You evaluate f double prime as 0. You will get a minus 30. And similarly, for a point bigger than 2.5, you are free to choose maybe let's say 5. Then you evaluate it for the function f double prime, so it's gonna be 30, and it means for the sign of f double prime, it's gonna be negative first, because it's minus 30 for the first value, for the second value is positive. So for the f double prime, it's all about the concavity. So before the point x equals 2.5, it is concave down. And after the point 2.5, it's going to be concave up, right? So let's write down the final answer to this table. So let's look at whether you have a point of inflection. The answer is yes, because right at this point 2.5 for the sign table of f double prime, you see there's a sign change for f double prime. So it means we have 1 point of inflection, which is when x is 2.5, and you have to evaluate f of 2.5 based on the original function f. Then you can get that the y coordinate of this point is actually 32.5. So we have only 1 point of inflection, and f is concave up when it is after the x value 2.5 up to infinity, and f is concave down for the interval of all values less than 2.5. So you need all this information, points of inflection. Where is f concave up? Where is f concave down? Local maximum values, local minimum values, and also where is f increasing, decreasing to sketch the graph now. So I plot the 3 points that you have based on our previous calculations. You see we have 3 points here. And because of the fact that, for example, like the right point is local minimum, so locally speaking, we expect a shape like this. And similarly, for the left point, 2, 33 is the local maximum, so we expect a shape like this. And because of the fact that, based on our previous table on the concavity, we understand that it's always concave down, it's always concave down for all the points less than 2.5. And similarly, it's always concave up for all the points bigger than 2.5. So I think the the shape of this graph is pretty nice, and if you want, you can also take a look at the sign table of f prime. So for f prime sign table, we understood that it's always going up before 2, and between 2 and 3 is going down, and after 3 is going up. So I think the red arrow fits in to our current green curve. So it looks like our curve is pretty good in terms of what we have for the information of f prime and f double prime. And of course, if you want, you can try to obtain more information before sketching the graph. For example, the y-intercept is gonna be f of 0, right? F of 0 is 5, and it means that this point is 5. So everything fits in nicely, and that's the basic way to sketch the graph. And of course, this problem depends on the function f also. For other functions f of x, to sketch the graph, it may not be that easy. We most likely may need more information like the vertical asymptote, horizontal asymptote, etc.